Alrighty, so today we're continuing on our notes on perpendiculars and distance. First, we're going to be looking at these images here. So we're asked to construct a segment to connect Q to line RS. In this case, we want the perpendicular line. Okay, this would be a long distance, but the perpendicular line, we will need to extend out our line RS so that we can create that perpendicular line from Q to RS, okay? The next example, again, we may not have to do that, so it says from H to FG. H to line FG is this way, so the perpendicular line in this case would go just straight there. All right, remember the perpendicular line is always the shortest. It's going to be the shortest distance. Okay, and then the last question, y to TS. So y is over here, TS is over here. If we drew a distance like this, it would be a little bit longer than this, but we know that a perpendicular line that would go straight down. So we have to construct TS a little bit more. And then y will just go straight down and create that nice 90-degree angle. Okay? So, as far as the distance between parallel lines, so we're asked to find the distance between the parallel lines L and M. Okay, so we need to find this perpendicular distance, and we're given the equations for line L and M. Since we have a perpendicular line going through, remember these are intersection points, therefore we're going to eventually need to do a system of equations. Okay, so system of equations to find those two intersection points, all right? So we already have one intersection point right here. Notice this is the y-intercept of line M. We just need to find this last point right here, okay? So we'll call this point Q, all right? In order to figure that, first we need to find the equation of our perpendicular line. So step number one, we have to find the perpendicular slope of line P. Okay, so we know that lines L and M are parallel and they have the slope of 2. Okay? Remember, perpendicular slopes are opposite reciprocal. So this means that for line P, our slope is going to be the opposite reciprocal of 2, which is a -1/2. Okay, that is our step 1. We now know the slope of line P. Okay, now we need to figure out the equation of this line. So this will be our step 2. Right, step 2, find equation of line P. Okay, so we know it has a slope of -1/2, and it's going through the point 0, -3. Okay, remember again, 0, -3 is actually your y-intercept of line M. This is very important because sometimes you might not be given another point. So, line M, use that y-intercept. If you have it on the line, go for it. All right, now we need to find the equation, so we're going to use point-slope form. So remember that's y minus y1, x minus x1. Okay, substitute in what we have, so y minus -3 equals -1/2 x minus 0. This minus a -3 turns into a positive. After we distribute out to simplify, we get y plus 3 equals -1/2 x. Okay, that 0 is just going to cancel out. Last step, get it in slope-intercept form. We are left with y equals -1/2 x minus 3. Okay, so our equation for line P is -1/2 x minus 3. Right? going back to the distance part, all right, now we know this equation. It goes through these 2 points. We have this one right here, but we need to find Q. Remember, in order to do that, we'll have to do a system of equations between this line right here, in this case is line L. So where line L and line P cross, it will give us Q. Remember up here at the top, line L is, equation is 2x plus 1. So we're going to continue on to step 3. Step 3. So use system of equations to find point Q. Okay, so point Q, remember, lies on line L, which is y equals 2x plus 1, and then it intersects with line P, which is y equals negative 1/2 x minus 3. For this system of equations, since we have an isolated variable, y, we can just substitute in this equation for y. That is going to give us y equals, or we're substituting y, so we have negative 1/2 x minus 3 equals 2x plus 1. Okay, this gives us one variable to solve for. We're going to get our x's on the same side. So 2x, right? Negative 3 equals, so we have 5 over 2x plus 1. Right, when we subtract that 1, we get negative 4 equals 5 over 2x. Okay, and then to get x by itself, we multiply by 2/5, or that reciprocal, giving us x equals negative 8 over 5. Okay, remember, the system of equations is giving us the coordinates of point Q, so we know that x is negative 8 over 5, and then you just substitute in x into one of the equations. So if we substitute in x into y equals 2x plus 1, we will have y equals 2 times negative 8 over 5 plus 1, which means y is going to give us negative 16 over 5, which gives us a total of negative 11 over 5. Okay. Now we know that point Q lies on negative 8 over 5 over negative 11 over 5. Or if you have this as a decimal, it is negative 1.6 and negative 2.2. Okay, so last step, we have to find the distance between point P and Q. So step 4, find distance between P and Q. Right, remember P was at 0, negative 3, and then Q we just determined negative 1.6, negative 2.2. Right, so we plug that in. P will be my 1s, Q will be my 2s. Negative 1.6 minus 0. Negative 2.2 minus a negative 3, which is just plus. Okay, so we get negative 1.6 squared plus 0.8 squared. Next step to simplify is going to be 2.56 plus 0.64. That gives us a total of 3.2, which is about 1.2.